Throughout section 2.3, we're going to look at many different applications, real-world applications where percents are involved. We're going to start off with sales tax, and then we're going to move through many other applications. And what basically all of these applications are going to use is the equation that we found in the last section. So remember, basically everything we did in the previous section's videos ended up just breaking down to this equation here, where amount equaled percent times base, right? And so basically all of these problems will use this equation as well, and it'll be our job to figure out what goes where. Am I looking for the amount? Am I looking for the base? Am I looking for the percent? And where does each number go? And then of course we'll solve these equations. So the first example says, how much is the sales tax on a $40 item at a tax rate of 8.2%? Okay. So of course in the case of taxes, the percent is always our tax rate, obviously. Okay. So I think it's really clear that if I want to set up this equation here, I know that 8.2% goes here, and of course we write it in decimal form, right? Remember that from the last section, that this percent in the percent equation is in decimal or fraction form. So I'll put 0.082 here. So now the question is, are we looking for the amount or the base? All right, so remember previously in a video we said that the base you can think of as the original, right? What you had originally. And in the case of taxes, the word original really applies to the original price before tax. Okay, so let's write that out. The base will be the original price, right? Pre-tax. And this makes sense, right? Because when you calculate the tax on something, you take a percentage of that original price. Well, remember, times means of, and so a percent of the base. So that's why the base is the original price. And so the amount, of course, is the tax amount. So in this case, what are they asking us to figure out? How much is the sales tax, or how much is the tax amount? So we don't know the amount, x. We do know the base, which is 40. So just working right off this equation. You can also arrive at the same setup by kind of writing out a little phrase like we did in the last section. You might say something like, what is 8.2% of $40? Right? So we saw a lot of problems that look like this in the last section. And of course, what turns to x is turns to equals 8.2% of turns to times. Right? So we get the exact same setup if you wrote out that phrase that you used in the last section. So whatever makes more sense to you, go ahead and use that strategy. But at any rate, we understand there's no solving of an equation to do here. All I have to do is multiply. So I have 0.082 times 40. And so put a 0 there. 4 times 2 is 8. 4 times 8 is 32. 4 times 0 plus 3 is 3. And there are 3 places to the right of the decimal point here, so I got to move my decimal back 3 places. And so x, or the amount of tax, is $3.28. Make sure we remember our labels on those. All right, let's look at one more example. It says a new DVD is priced at $18.50, and the sales tax is $1.33. To the nearest tenth of a percent, what is the tax rate? So here it's pretty clear what they're asking us for. They're asking us for the tax rate, which is the percent. So in our amount equals percent times base equation, percent is our unknown. So the only question is, what do we put in for the base? What do we put in for the amount? Well, again, a new DVD is priced at $18.50. That's the original price before the tax is applied. So that belongs as our base. I'm just going to put 18.5 there. And so then that would mean $1.33 is our amount, which makes sense. That is the amount of sales tax. Let me clean this up real quick. Put my 18.5 in front. And of course, we isolate x by dividing by 18.5 on both sides. Okay, so we have x by itself, but of course we need to perform this division. So I've got $1.33 divided by 18.5. And I know that I can't leave that decimal point in the divisor. I've got to move the decimal point over 1 in both numbers. So the divisor is not a decimal anymore. And so the division problem that I really have here is 13.3 divided by 185. Okay, so 185 does not go into 13, so we put a 0 there. Decimal point, it does not go into 133, so we'll put a 0 there. Alright, so we add a 0. 185 goes into 1,330 about 7 times. Okay, 7 times 5 is 35. 7 times 8 is 56, plus 3 is 59, and 7 times 1 plus 5 is 12. Alright, so we need a little subtraction there, and we're going to need to do some borrowing. So that'll be a 10, of course. This will become a 2, and I'm going to need to borrow 1 from there and make that a 12. So I've got 10 minus 5 is 5. 12 minus 9 is 3, so a remainder of 35. And what did it say? It says to the nearest tenth of a percent. So remember, decimal moves over twice, so we're at the nearest whole percent with this digit. So to get to the tenth of a percent, we'll drop another 0 down. Let's see, 185 goes into 350 just twice. Excuse me, not twice, just once. So 1 times 5 is 5, 1 times 8 is 8, 1 times 1. Okay, so we've got 10 minus 5 is 5. We had to borrow here. 14 minus 8 is 6. 2 minus 1 is 1. Okay, now we're at the tenth of a percent place here, but we need to add one more 0 to see how many times 185 goes into 1650, so I know whether to round up or down. And it turns out we get an 8 here. Okay, 8 times 5 is 40, 8 times 8 is 64, plus 4 is 68. And so that's going to be a 14. Okay, so what we can do now is round this to 0.072, but that of course is not our answer because that's a decimal form of a percent. So our answer is that the tax rate is about 7.2%.